Hello everyone, welcome back to the channel, and today we have a question from calculus which you can see on the screen right now. We have been given a function. By the way, this is my first video on mathematics on the channel. I mainly post physics, you know well, but I thought about posting a little mathematics today because Advanced 2024 is only 3 days now. Anyway, so if any 2024 aspirant is watching this who is going to attempt his paper on this 26th May, then it is, I mean, very important for him, as this video will also be a revision for almost all concepts of calculus. Okay, such question is this. This is, I mean, that's why the title says that monster question from calculus. It's really a beautiful, very beautiful question, and it's very hard to do in examination. Anyway, so we have been given this expression, and we have been given the range of x. So we have 4 options, and we have to say which of these statements are true. And also we have that f of pi is equal to 0, and also that f of pi by 6 equal to 3 by pi. I don't know why this is given, because when I solved, this condition was enough for me. Anyway, so let's proceed with the solution. So this was the given expression. Now I am pretty much sure that you know the L'Hopital's rule, which is basically a rule for limits, for determining limits. The rule is, if you do not know, I mean, if you know, then just skip the next 20 or 30 seconds. But if you do not know, then L'Hopital's rule basically states that if the expression inside the limit, if that is in 0 by 0 or infinite by infinite such forms, then you can simply differentiate the numerator and the denominator by the same variable. Which variable? For here, this t variable, the limiting variable. Okay, so we have done that here. So we have got this expression. You can differentiate it for yourself, and here we have put t is equal to x. Okay, so we obtain a differential equation, and this is a linear differential equation with coefficients, with variable coefficient. Anyway, so to the general method to solve this type of differential equation is basically to calculate the integrating factor, and then to multiply with them in the both sides. But anyway, this was visibly, the integrating factor was cosec squared x, because we needed this right hand side to be 1 by x squared. Okay, so I mean, that was my observation. If you did not have that observation, you can also calculate e to the power integral of p dx. That's your integrating factor. And what is your p here? Your p here is basically you have to take it here, so it will be just minus cot x. Okay, so anyway, we will have this expression, and at the end you obtain f of x equal to sin x by x plus c, and if you put this condition here, f of x will just come out to be sin x by x. Okay, so one part is done. We have obtained our f of x, the function, and now we have to comment on maxima and minima. So this is the first derivative, and for maxima or minima we need this equal to 0. So here you can clearly see that the solution for this equation, cos x by x minus sin x by x squared, so this will have a solution at x equal to tan x, and the interval in which we need to obtain the maxima or minima, that is our pi to 2 pi. And if you can check it by drawing graph, that x equal to tan x has a solution in pi to 2 pi. Okay, so you can check it by graph, but I didn't need that, because this x equal to tan x, if you have studied wave optics pretty deeply, I am talking about single slit diffraction. Some of you have probably studied it, that in single slit diffraction, beta is equal to tan beta. That is the expression for the maximas, in which the fringe is the brightest. Okay, for bright fringe, beta is equal to tan beta is the equation. At that beta, or at that position, we obtain the bright fringe. Okay, so similarly from that, I had just memorized that the solution of this between pi to 2 pi was the first solution. It has many solutions, but the first solution is basically x is equal to 1.43 pi. Okay, I mean after 0, of course after 0. Okay, at zero in diffraction you have the central maxima. We are not talking about that here. So anyway, and this gives us that we will have a maxima or a minima in the given interval. And now we just calculate about f double dash of x. So this is coming out to be a what you call Ganda expression, and then you finally got this. Okay, this is pretty much calculative. Anyway, and now you have to see that if it is negative in any point, positive in any point, or maybe negative in whole, positive in whole, whatever. So if you see in pi to pi interval, this sin x by x, sin x is also negative, cos x is also negative. So this term becomes positive. This term becomes positive. This term is negative, but this is always smaller than, I mean, this is just common sense. This will be smaller than this, because the interval is pi to 2 pi and pi is larger than 2. So this negative will be small, magnitude of this negative will be smaller than magnitude of this positive. Okay, so that gives us what? That f of a f dash double dash of x is greater than 0 in all of pi to 2 pi. Okay, so from that we have conclude that f double dash of x greater than 0, that is the condition for our minima when f dash of x equal to 0. So this option becomes correct and this becomes wrong. Now coming to the tricky part. So for this I want you to remember or see the Taylor series of sin x and cos x, and you also need to remember that of e to the power x and log 1 plus x. This Taylor series thing is very much important, let me say that. Okay, and now we had the integral, and I hope you know this too, that if f of x, let me tell you just that if f of x is less than g of x in any interval, then the integral of f of x in that interval from a to b, let's say, that will also be less than the integral of g of x in that interval a to b. Okay, so and now you also know that sin x is less than x for all x belongs to real number, because you know this, right? So I mean, if you have studied maxima and minima, so I mean you can prove that there. But this property holds, and you all should know this. This is very elementary thing. Okay, so in that case, so we now sin x by x is less than 1. So x into f of x, this will always be less than x. So this becomes less than half. Okay, we have found out the upper bound for this integral. And also, if we evaluate the integral, this is sin x dx integral from 0 to 1. This will be cos 1. And now let's apply the Taylor series. Okay, so you can see from the Taylor series of cos x that it is 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial, and then there is a minus. Okay, so if we consider up to this, third term, okay, so cos x will be less than that. So 1 minus cos x, the 1 minus cos 1, that will be greater than this if we consider cos x up to third term. So this will just come out to be greater than 11 by 4. I mean cos x is cos 1 is less than 13 by 24. So this will come out to be your 1 minus cos 1. This will come out to be your 11 by 4. Okay, 11 by 24. I'm sorry. And so the range is 11 by 24 to half. So that from that we conclude that this option is also correct, option D. And now let's move on to the last option, option C. So this one is a little more trickier, and see, let's do the upper limit first, because that is of course more that's more easy. So this, from the previous rule, f of x is less than g of x, that implies that if integral of f of x in some interval will be less than in the integral of g of x in the same interval. So from that we can conclude this x squared into f of x, that is basically your x into sin x. So that will be less than x squared. So the integral is so, and this integral is 1 by 3. So we have the upper bound, that is 1 by 3. And now the tricky part comes, which is the lower bound. Okay, so this part was the last part of the problem. So if we work out this integral, this will come out to be sin 1 minus cos 1. I mean, it's just integral of x sin x dx. The interval is from 0 to 1, and this value, okay, so you can integrate by parts and obtain this value. So now see one thing, that for the maximum value of this, the minimum value of this integral, we need the minimum value of sin 1. We need the minimum value of sin 1 and the maximum value of cos 1. Okay. So now from here, Taylor series, we can write that this is 1 minus 1 by 6 plus 1, I mean just 1 minus 1 by 3 factorial plus 1 by 5 factorial. This is to the power 3, 5, and there this would be a minus, right? A minus 1 to the power 7 by 7 factorial. So if we neglect that term, so sin 1 will be less than this term. So if you work it out, it is coming out to be 101 but divided by 120. Okay, and now cos 1, this will be greater than this. I mean, similarly here will be a plus term, so, and the plus term is greater than all of the rest minus terms, so this will be greater than this. And if you just neglect this 1 over 6 factorial, then cos 1 will almost be equal to 65 by 120. Okay, so from there we conclude that sin 1 minus cos 1, this is basically 101 minus 65 divided by 120, which is 36 by 120, which is equal to 3 by 10. So we also have the range of this integral, and this lies between 3 by 10 to 1 by 3. So from that, this option 2 becomes correct. So our correct options are A, C, D, and that brings us to the end of this question. And I hope you really liked this question. This was literally a monster question for JEE. So I mean, let me tell you that you revised all of your concepts doing this question or watching this video. I mean, there had been limits, there had been differential equation, there was your Maxima Minima, there was Taylor series, and there was your I don't exactly remember the rule, that rule, integral of fx less than integral of gx, Leibniz rule or whatever it would be, but that is another rule. So, and also you practiced a little bit of definite integral too. So that is almost 5 to 6 concepts inside one question. So I mean, I have nothing more to say. I really hope that you like the video, and it was if you have watched till now without skipping seconds, I mean without skipping anything, then you have, congratulations to you, you have devised almost of your whole calculus. Okay, so thank you for watching, and I mean continue your preparation for this last 3 or 2 days you have, if you are watching before 26th May, and I am happy that I could make you revise the whole calculus in one single, probably 14 or 15 minute video. But anyway, keep solving problems for now and keep revising, and I will try to bring 1 or 2 more videos before your advanced, and till then just stay tuned, and that's it for today. So bye bye, and I will see you in the next video.